I'd like to make a commentary regarding the definition of function. And for that, let's use our previous examples where we defined the relations f and g, which were constructed from the sets big X and big Y. Right now, we want to understand why is it true the statement f is a function, but using rigorous mathematics. Previously, we concluded that f is a function using your intuition, but right now let's use rigorous mathematics to understand why is this thing true. Also, we want to understand why the statement f is a function, why is it a false statement. So let's rewrite this thing, which is in English, into mathematical language. So this thing is equivalent to saying that for all x living in big X, there exists only one y that makes the pair xy in F. I'll read it again. For all x, and so for A and B and C, what is written here must be true. And what's written here? Well, there exists only one y, so either y is 1 or is it 2, that makes x and y in F. Okay? So, if this thing is too confusing, let's unpack it further. Because in turn, this thing is equivalent, this entire statement is equivalent in turn to this. There exists only one y that makes a y in F. And let me write it like this. Maybe it's more intuitive. And there exists only one y that makes by in F. And there exists finally only one y that makes cy in F. This thing is a compact version of this string of ends. And if you recall, the string of ends is true if each one of these parts is true. So this is true, and this is true. So let's evaluate the truth value of each. Is it true or is it false that there exists only one y, so y is either 1 or 2, that makes a y in F? Well, when y is 1, you have a 1. Is it true that a 1 is in F? Well, it's true, it's here. When y is 2, is it true that a 2 is in F? No, it's not. So there is no other y that pairs with a that makes that pair in F. And so we conclude this is true. There is exactly only one y, in this case 1, that makes this thing true. Let's look at the second one. Is it true or is it false? There exists only one y that makes the pair by in F. Well, when y is 1, we have b1 in F, it's here, it belongs. When y is 2, well, b2 is in F. No, it's not. And so there exists only one y in y, big Y. So there is only one y living in big Y. In this case, y equals 1. That makes this thing true. Okay? So this part is also true. Finally, is it true or is it false? There exists only one y that pairs with C. So there exists only one y in here that pairs with C, that makes in turn cy in F. Well, it's true. When y is 2, you have C2, and C2 lives in F. It's here. So again, this is true. Now, because this thing is true, the entire thing is true, this thing is true, because this statement is equivalent to this one, this entire thing is true, and finally, because this thing is equivalent to this statement in English, this is true. Okay? Now, let's look at G. And instead of writing this thing again, let me just replace the F by the G. So this is G, G, and G, and G. And the equivalence here now is downstairs. Okay? Now, For all x, there exists only y that makes a pair in G and packs into this thing. Let's analyze each one. Is it true or is it false that there exists only one y in big Y that makes pairs in G? Well, when y is 1, you have a 1. Is it a 1 in G? It's here. When y is 2, is it true that a 2 is in G? Well, it's here. And so, the statement that there exists only one y in here that makes a pair in G is no longer true, it's false. There are in fact two y's. Either there are two values in big Y makes the pair in G. Okay? Now, I think it's easier now to see that these two are in fact true. Okay? When y is equal to what? 1. There is only one, by the way. There is only one y here, one that makes a pair in G. It's here. And the same for C. When y is 2, it's here. Okay? But because this is a string of ands, and, this entire thing is false. Because you have an equivalence, this thing is false, and finally, G is a function, is a false statement. Now, let's now recap the central idea that we are seeing here. Now, not only you are translating from here to here and then unpacking it further, there is something else going on. And I would like to write it like this. Let me just erase this, because I want to focus just on this statement. And instead of putting some letter here, let's put a box, because the box, it can put any relation here. So this is the idea. You have this statement, and x is what? X is fixed. You see, when you introduce here a relation, that relation was constructed from some set. In this case, x and y. So this x belongs to big X, and y belongs to big Y. So our starting points, the sets x and y, are already fixed in general. Only when you have x and y, then you construct the relation. Okay? And the relation that you construct can be many things. So there are many possibilities to introduce here just for the same x and y. Okay? Now the idea is that you start with x and y, there are many relations. For some, this entire statement is true. For others, it is false. Okay? So essentially, this statement is analogous to an equation. For example, when you have x squared is equal to 9, well, this variable x is just a placeholder for some real number. For some real numbers, this thing is true. For others, it is false. For example, when x is 1, 1 squared is 1, 1 equals 9. This is false statement. But when x is 3, it is true. 3 squared is 9. Similarly, so this is a box where you introduce many possible numbers. Similarly, you have here this placeholder. You can introduce here not a number, but some relation that was constructed from x and y. And so this statement, or should I say this equation, is true for some relations and false for others. In particular, when this relation is a function, like in for example f, this thing is true. Okay? So this is the main idea that I want you to get, to understand the meaning of function, but now starting from the logic and the rigorous mathematics and connect it with your intuition.